Okay, this is still working on worksheet point 4, and this is problem 11 through 15 I'm going to do. Alright, so it says limestone, which is calcium carbonate, can be used to produce calcium carbide, which is what I use when I do demonstrations where I want to explode stuff. It makes acetylene gas. It's actually pretty exciting. Okay, so the process is started with 50 grams of calcium carbonate, and you get a 75% yield. What mass of calcium carbide can be produced? Okay, and it gives us balanced equations, and I can see that for every one calcium carbonate, I make one calcium oxide, and that one calcium oxide gives me one calcium carbide. Okay, so that's going to be useful to me. And because I'm looking for 75% yield, I'm going to figure out how many grams I can make, and I'm just going to multiply that times 0.75 when I'm done to get it down to a 75% yield. Okay, so I'm going to start with something I can weigh, or something I can measure, which is 50 grams of calcium. I'm just going to call it CC, calcium carbonate. And the molar mass of calcium carbonate is just about 100 grams per 1 mole of calcium. I'm just going to call it C and then O3, calcium carbonate. Remember, you don't have to show your work for these, so you want to, it's all about working fast. So for every 1 mole of calcium carbonate, I get 1 mole of calcium carbide. And 1 mole of calcium carbide, let me see, calcium is about 40 grams, carbon is 12, there's 2 of them, that's 24, that's 64 grams. Okay, is 64 grams. Alright, so let's see what I can cancel out to make this easier. I can cancel the 50 and 100, and that becomes a 2, so I end up with 64 over 2, which is 32 grams. That assumes 100% yield, that everything reacts, but I know it's 75% yield. So the way I think about 75% is I think about 50% would be 16 grams, and another half of 16 is 8. I add those together and I get 24. Okay? Alright, number 12 says, consider the reaction 2 aluminum plus 3O2 give me 2 aluminum oxide. Which expression approximates the volume of O2 when measured at STP when 55 grams of aluminum reacts with excess O2? Okay, so I'm going to take 55 grams of aluminum. That's my weighable amount. And the molar mass of aluminum is about 27. I'm not going to write 26.98. 26 grams of aluminum is 1 mole of aluminum. Based on the balance equation that gave me 2 aluminum requires 3O2. And 1 O2 requires 22.4 liters. Okay. Now, if I look at the answers, they are not asking me to come up with an actual volume. They are wanting me to show which factors I have that are going to give me the answer. So let's just break these factors down then. The last factor is 22.4 liters, right? And they all have that. The middle factor is the mole ratio, and what they're looking for is, did you put 3 over 2 or 2 over 3? And if you put 3 over 2, you can eliminate choice C and D because their mole ratio there was 0.67. So the first factor then is how many moles of aluminum do I have? And I've got 55 over 27, which is almost exactly 2. It's not a half, so they want to make sure the 55 is on top. So the answer is going to be A. All right. Let's take a look at 13. 13 I think is a little bit complicated. It says, assuming an equal mass of nitrogen in each compound, which oxide of nitrogen contains the greatest number of moles of oxygen atoms? Okay, equal mass of nitrogen in each compound. I'm going to say let's assume I have 14 grams, because if I have 14 grams then I have 1 mole, right? So if I have 14 grams of nitrogen in there, I have 14 grams is going to be 1 mole of nitrogen. So I'm going to end up with 16 grams of oxygen, or 1 mole of oxygen. So I'm going to have 1 mole of oxygen here, because I have 1 mole of nitrogen. Alright, if I have 14 grams of this, I'm only going to have a half a mole, or I'm going to only have a half a mole of this, because if I had a mole of something that contained N2O3, I'm going to have 28 grams of nitrogen, because there's 2 of them, right? So I'm going to have a half a mole of the compound, which is going to equate to, because I've got 3 oxygens in each, a half times 3 is 2/3, right? So that's going to be less. Alright, I have NO2. If I have 14 grams of N, right, then I'm going to have 2 moles. I'm going to have 1 mole of oxygen, and I'll have 2 moles of oxygen. So far C's in the lead. Alright, if I have N2O5, and I only have 14 grams of oxygen, I can only have a half a mole of that. So I'm going to have half a mole of N2O5, right? If I take a half and I multiply it times the 5 oxygen atoms of each of those, I end up with a half of 5 is going to be 2.5. So the one that has the most oxygen, has the greatest number of moles of oxygen, is going to be D. Okay, a little bit complicated, that one. Alright, let's take a look at 14. When the equation for the following reaction is balanced using smallest whole numbers, which gives a correct description of the information in the equation? Okay, so I've got to balance it. Now, when you are balancing something and you have the same polyatomic ion on both sides, you should start by balancing your polyatomic ions. It's going to make it easier for you. So let's look at the nitrates. I have 3 nitrates here. I have 2 nitrates here. So I'm going to have to multiply this one times 2 and this one by 3. I'm sorry, vice versa, 3 and 2. Same thing with hydroxides, 2 here, 3 here, so I'm going to multiply that times 2 and that by 3. So let's take a look at our choices. The sum of all coefficients is 10. 2 plus 3 is 5. 2 plus 3 is 5. Total is 10. I am done as long as I trust myself. Figuring out all these things is going to take some time. So I would answer A and move on. Alright, question 15. Which oxide of vanadium contains the greatest mass percent of the metal? Okay, so if I look up vanadium, it's got a molar mass of 50.94. So I'm going to call that 50. It's got a molar mass of 50. So in A, I have 50 grams of vanadium, and I have 16 grams of oxygen for a total mass of 66. Okay. For V2O3, I have 2 vanadium, so I'm going to have 100 grams of vanadium, and my total mass is 100 grams of vanadium and 48 grams from those 3 oxygen for a total of 148 grams. If I take VO2, I have 50 grams of vanadium in there, 50 grams of vanadium plus 32 grams of oxygen from those 2 oxygen, so that's going to be 82. Okay, and if I take V2O5, I've got 100 grams of vanadium, and I'm going to divide that by the total molar mass, 100 for vanadium. 5 oxygen, 16 times 5 is going to be 80, so the total mass there is 180. Okay, so in order to be able to compare these directly, I'm going to take it just a step further. Some of you can just look at these numbers and know which one is going to be the greatest mass percent, but I'm going to make them all ratios with 50 on top. So if I divide that by 2, I'm going to divide that by 2, so that's going to be 74. This is going to be equal to 50 over 90. Okay, so here's 50 over 66, 50 over 74, 50 over 82, and 50 over 90. Dividing by the smallest number is going to give me the largest result, so the answer is going to be A. Alright, we're going to stop right there.